second midterm on Thursday. And what we've been doing recently, and the stuff that's going to be on the midterm, is all around limits, intro to derivatives, like continuity, the differentiability, and stuff like that.
Calculus.
Yeah, the real deal.
Everything you mentioned is calculus, starting with a limit.
Mm-hmm. Yeah, so
it's. So what do you got tonight?
Let's see. I have a practice midterm up here. I don't really have anything specific, but if we could do some, actually, let's see here. Let's go through, this is just problem number 1 on the practice midterm.
Okay.
And it's a 3-part problem. And it says, throughout this problem, let f of x equal x squared plus 3x raised to the negative 2 minus 4. Okay. And then part A says, find the slope of the tangent line of f at x equals 3.
Okay. The slope of the tangent line is the first derivative.
Okay. And
so what we're really going to want is f evaluated at, what was it, 3?
Yes, x equals 3.
3 or minus 3? 3?
Positive 3.
Okay. So that's what we want. Now, have you learned the power rule yet?
We have, but the way they do it is a little interesting here. Mm-hmm. So we started learning that today, but it's actually not going to be included or allowed to use on the midterm. So how we've done this so far is we have to use like the definition of the derivative, like
so you're using this definition.
Yeah, exactly. Yep, that one.
They always make you do it the hard way before they teach you the easy ways.
Yeah.
And this is going to be relatively hard to do this way.
Yeah, this is what's the most confusing for me.
Okay, well, the way to do it is, we know what f of x is, right? So we know what that is.
Yep.
What we need to figure out is what is f of x plus h.
Okay.
So what would that be?
That would be, so everywhere there's an x, you'll plug in a plus h as well. So the numerator is going to be x plus h squared plus 3 times x plus h raised to the negative 2 minus 4.
Okay. So that is my f of x. Okay. Now, I'm going to subtract from that. But in order to do it, let me go ahead and, let me write this expanded, because you always have to expand the f of x plus h.
Okay.
Okay. So I get that. And then to expand this, that's really 3 over x minus h quantity squared.
Yep.
Minus 4. Okay.
Okay.
And then I'm subtracting from that the quantity f of x. In other words, what I just wrote was f of x plus h.
Okay.
So to subtract f of x, and notice the parentheses. I need those parentheses. If I don't have them, I'm going to get the sign wrong because this negative sign has to be applied to all three terms.
Right.
Okay?
Okay.
Now, let's do the easy part first. We notice that if I remove the parentheses, let's do that. Let's put a negative sign there, a negative sign there, and a positive sign there.
Okay.
Now here's what we have. I'm going to write it over here on the left. X squared plus 2xh plus h squared plus 3 over x minus h squared minus 4 minus x squared minus 3 over x squared plus 4. Okay?
Okay.
Now, whenever you apply this limit definition, you will realize that every term in the numerator that does not have an h in it disappears. In other words, my x squared disappears because of that x squared.
Yep.
My 4 disappears with that 4.
Yep.
So what I'm left with, and I'm just working in the numerator here,
Okay.
is 2xh plus h squared plus 3 over x minus h squared minus 3 over x squared. Now, the reason this becomes tough is because the algebra is tough. In other words, it's not so much the limit definition, it's how to do this subtraction here.
Right.
Well, how do I subtract two things with different denominators? In other words, this is what I got to figure out how to do.
Right.
So what
So
do
we
I?
got to get a common denominator.
Okay. So now I'm going to write. The common denominator is going to be the product of these two things. In other words, my common denominator is going to be x times x minus h quantity squared. Excuse me, x squared times x minus h squared.
Okay. That makes sense.
And the upper left, in other words, here, let me write it as two things. This upper left has to be that, right?
Mm-hmm.
In other words, I know that the x squareds cancel and I have what I started with. And that's always what you want to make sure you have, is what you start with. Both of those fractions are the same as above.
Correct.
Okay? Now I can combine the numerators. But before I do it, I got to multiply out that x minus h again. So let me do that. So that becomes 3 times x squared minus 2xh minus h squared.
Mm-hmm.
And now it becomes 3x squared minus 3x squared plus 6xh plus 3h squared all over its common denominator Like I said, the algebra is nightmarish.
Yeah, this is not fun.
It's never fun to do these limit definitions.
Yeah.
Okay. And all of that is over h. But again, let's look at that numerator.
I see some things we can cancel.
Yeah, that cancels.
And then we can combine.
We have the following. Whoops, hold on. Nah. Trying to figure out how to use this problem. I'm not having a lot of luck. This program.
Yeah. Oh yeah, you got the new program. I forgot about that.
Okay. So what do we have here? We have, I'm going to start further to the left now. I have 2xh plus h squared. And I have nothing but plus signs. So I have 6xh plus h squared all over that common denominator. And all of that is over h.
Jeez. Okay.
Now, if I treat the bottom like a fraction, flip and multiply, that's what I want to do.
Yep.
Okay. Okay. So when I flip and multiply, it takes out that h, leaving me with that. I still have one h there.
Yep.
Plus 6x plus h, and I still have that denominator.
Okay.
And I've gotten rid of the h that was in my original denominator.
Right.
Okay. Now, the question is what is the limit of that as h goes to 0? We still can evaluate it as h goes to 0.
Right.
Well, unless I've done some math wrong, it looks like 2x plus 6x over x to the fourth, which is 2x plus 6x to the minus third.
Yeah.
There's our answer. Now, let's look at the power rule. What was the original function?
Here,
let me scroll.
X.
Just a second. Before
X squared.
Let me scroll down so I can write it. Okay, what is it again?
X squared plus 3x raised to the negative 2 minus 4.
Use the power rule on that. That's f of x. What's f prime of x?
So the power rule.
Start with the exponent, multiply it by the coefficient, subtract 1 from the exponent.
So 1.
2x.
Oh yeah, 2x. Okay. Yeah, we just started learning those rules today, so those are still a little shaky.
The only reason I'm doing the power rule is to make sure we got the right answer.
Right.
In other words, when I apply the power rule there, it's minus 2 times 3, which gives me minus 6. And then I subtract 1 from the exponent, which makes it minus 3. And then the power rule on that makes that go away.
Yeah.
So my only question was the original function plus 3x or minus 3x?
Maybe I said it wrong.
No, you might have said it right, and I might have made a mistake when I did the limit definition. I might have got the sign wrong on that.
Yeah, it says plus 3x
Okay,
to
if
negative
it's
2.
plus 3x, then this is definitely the derivative.
Gotcha.
Okay?
Yeah,
Now,
it's annoying that they make us do the long way when we can just,
you know, for the life of me, I've never been able to understand it. You would think
yeah,
that when you're teaching somebody calculus, you start with the easy method first, and then you do the medium method, and then eventually you do the hard method.
yeah, exactly.
You don't start out with the hardest method first, and that's what
No,
they do when they insist that everybody learn this limit quotient definition.
yeah,
Now, it's not, the algebra isn't always this hard. The algebra is particularly hard when you have a denominator that's the variable. In other
right.
words, because I had an x in the denominator here, it made the algebra super tough.
Yeah,
And I made a mistake, obviously, in doing, I don't think it's worth us going back and seeing why I got a plus sign instead of a minus sign.
I don't think so either. Because like I get the concept now. Before it was just like
Okay.
a little shaky.
It's,
But
I tell you what, it would be a little easier if we didn't tackle such a tough one. Let's do just a little easier one,
okay,
and we'll be able to do it real quick. Let's just say y equals x squared. And I want to figure out the derivative of that. So that's f of x. So what is f of x plus h? Ah, that was our problem. I was doing f of x minus h, wasn't I? Yeah,
maybe.
that's why I
Yeah,
got my sign wrong, because I used
yeah,
minus.
yeah.
It's plus h.
There it is.
And the reason I'm disappointed in myself, because to all high school students, I always tell them that it's always x minus h until you get to calculus. That's the first time you run into an x plus h.
Plus H. Yep.
In algebra, when you're doing conic sections, when you're doing vertex format, it's always x minus h, it's y minus k. And so it's not until you get to calculus that it's x plus h. Well, what would x plus h be? That.
X plus H squared.
So our formula is f of x plus h minus f of x all over h. So f of x plus h is x squared plus 2xh plus h squared minus f of x, which is just that.
X squared.
Again, notice that every term that does not have an h in it goes away.
Mm-hmm.
And now I can factor out an h, divide top and bottom by h, and I get this. And I want to take the limit of that as h goes to 0. Well, as h goes to 0, that just goes away. And I end up with 2x.
Mm-hmm.
And using the power rule, you end up with 2x. But notice the algebra wasn't nearly as tough here. I didn't have any denominators. I didn't have to find a common denominator. I just had to expand x plus h squared.
Yeah.
And then
that
operate on the numerator.
And that's also the kind of annoying part about these problems is because like I'll understand the concept, but then they just make the algebra part like really challenging.
Yeah, no, I get it totally. I don't understand it. I got another calculus student right now that they give him these ridiculously tough problems that aren't tough from a calculus point of view. They're tough from an algebra point of view.
Yeah.
And some of the algebra is just outrageously difficult. I mean, it's
Yeah, like I don't think I would have been able to to get that last one without a little help on it.
Yeah, it's hard when you have the variable in the denominator.
Yeah.
So, but if everything's in the numerator like that, or even if I made it x cubed, I'd be able to do it rather easily. Although if you made it x cubed, then you would have to cube that x plus h, and that's a little tougher to do also.
Yeah.
So, different functions have varying degrees of difficulty doing it by the limit quotient method. And once you get by this, once you do it for however long they're going to force you to do it, maybe a week, then they teach you the power rule, the product rule, the quotient rule, and the chain rule. And you can do all of your differentiation using those 4 rules. And you never have to go back and do this again.
That sounds nice.
Yeah, it does. I just don't know why they start you off with it. If they were attempting to demoralize a new calculus student, this is the way to do it.
Yeah, this part's definitely been pretty challenging.
Yeah, and it's a lot like a lot of math. Every math discipline tends to start out with something really tough. When you took Algebra 2, you might have started out with linear programming. Well, that is always the toughest part of Algebra 2, and yet they start you out with it. You take geometry, they start you out with proofs. Well, proofs are the toughest part of geometry.
Yeah.
And this calculus, where they start you out with this limit quotient definition. That is one of the toughest things you're going to come across in calculus. Just because the algebra is tough. It's not so much, it's not hard to figure out what f of x plus h is, subtract f of x, but then the algebra and simplifying that becomes pretty tough.
Exactly. So, yeah, it's just it's also kind of like just interesting the teaching style, like I said before, because they taught us like the power rule and the sum rule and the difference rule today.
Okay.
But we're not allowed to use it on our
right.
midterm on Thursday.
That's because everybody would, and nobody would.
Yeah, exactly. So it's just a little frustrating.
Yeah. Well, I'm glad to hear you're in calculus, and I can assure you that once you get by this part, it'll actually get easier for a while.
Good.
Because once you use the power rule, these become a lot easier.
Perfect. That's what I needed to hear.
Yeah. No, it does. So I'm going to let you go tonight because I have a 7:30.
All right.
But I made a appointment for tomorrow night, so I will talk to you tomorrow night at 6:30 my time, which is 8:30 your time, right?
8:30 my time.
Talk to you tomorrow night, Casey.
Perfect. Sounds good.